Before we begin? That means
Yes.
everybody, okay.
So you emailed it to the GA, right? How is it the email? You email the GA
For the assignment?
Yeah.
Yeah. I think I put the information on the website where you have to email. I think the email was something like CS440 fall 2015 at yahoo.com. And you'll zip your project, also create a small Word document with some screenshots.
Yeah, how do we show the information when we create an object? To the console or?
Oh, for this one, it's the final UML that's more important.
Okay.
So you don't have to worry about any object creation.
Okay.
All right, so looking at the object-oriented programming fundamentals, right? So encapsulation, which is creating the classes, the private, public, protected declarations. Okay, so creating a class. Okay, and the private, public, protected keywords. Okay, that was our encapsulation mechanism. Then we discussed inheritance. Okay, so here we create some base class. From here we can inherit another class or more than one class, right? Okay, so remember, you do not create the base class first. First, you create the actual classes that represent the physical things in your system. And as you create those classes, you take a look at the common things that are appearing. And whatever things you are duplicating, you'll take those common things and move them into the base class. Okay. So this is called the base class. This is called the derived class. Okay, and sometimes people call this the parent class or the child class. Okay, it doesn't matter, right? Okay, so through the university application, hopefully you guys have gotten a good idea of this. And once we use inheritance, we run into keywords like abstract, override, and virtual, correct? Okay, so if this is the top level base class, and if there's a code that exists in the method, then how will that method be marked if we wanted to allow this to be overridden in the derived class? Virtual. If this is the top level class and there's no code over here, so just a declaration of the function, what inputs it takes, what output it gives, then how will it be marked? Abstract, right? Okay, so regardless it's abstract or virtual over here, if we override it and provide our own code over here, can we further override it from here?
Yes.
Yes. So from an override, you can further change the code over here, and we can do another override, right? Okay, so those were the key concepts that we ran into once discussing inheritance. Okay, and last lecture we were looking at polymorphism, which is the third fundamental concept in object-oriented programming. And polymorphism, as we discussed in the last lecture, poly means many. Morphism basically means forms. So in terms of programming, think of it as many forms of a function. Or in other words, a function or many functions with the same name. So many functions with same name. Okay, so as we discussed, polymorphism can occur in two different scenarios. One was a very simple scenario So one is within the same class. So within the same class. Okay. Now this is a very easy form, and a lot of people do not consider this to be the true polymorphism. But if we strictly go by the definition of many forms of a function, it could be qualified as one form of polymorphism. So this is called method overloading, right? Okay, so again, the idea was if you created some class, let's say XYZ, okay, suppose you created some function in it, public, double, let's say compute something, int A, int B, right? And you wrote some code in it, whatever that code is. Okay, so the question is, can we write one more method over here, which is also called compute? Okay, and the answer is yes, we can do that, as long as either the number or the type of parameters is different. Okay, so for example, what if I did this, float A, float B? Will this be allowed?
Yes.
Yes, because the type of the parameters is different. Okay, so I remember the rule in overloading was we can overload a method as many times as long as either the type or number of parameters is different. Right? So this was the rule in overloading. So these two are perfectly okay, correct?
Yes.
So what if I do this? So instead of second being float A, float B, I also do int A, int B, and add a third parameter, int C. Will this be okay? Can
Yes.
both of them exist in the same class?
Yes.
The answer is yes, because now it has 3 parameters. This only has 2 parameters, right? So that's perfectly okay. What if I do this? Leave these as 2 parameters, int x, int y.
No.
I change the name of the parameter.
No.
No, because see, it doesn't matter what name we give it, the data type is the important. It's int. So 2 parameters, both are int, so this will not be allowed, right? Okay, what if we do this? We make it int x, int y, but the return is, let's say, int, rather than double.
No.
Yes or no?
No.
And the answer is no. Take a look over here. We don't talk about the return type, only the parameters. So if there are 2 parameters, both are int, this will not be allowed. Okay. So anyway, that's called the overloading. Okay. And as you already know, we often overload constructors. Because remember, constructor is like a method, right? Okay, so that was the easy form of polymorphism. Now let's take a look at the tricky form of polymorphism, or the more useful form of polymorphism, and that occurs when we are between a base and a derived class. Okay, and this is called overriding, basically. So it occurs whenever we run into overriding. Okay, so now the key concept to remember over here was number 1, okay, base class reference can point to a derived class object. So this is true not just C#, but all object-oriented programming languages. So all OO languages allow this concept, okay? Without this concept, we won't be able to create sophisticated programs where we have many classes and some relationships between those classes, right? Okay, now coming to polymorphism, what it means over here is, so first let me describe it in plain English, then I'll give you examples. So in plain English, the polymorphism, so this polymorphism over here occurs like this. If a base class reference is used to point to a derived class object, just write it together, to a derived class object, then the call to a method from the base class reference should execute correctly. So that's the goal of the polymorphism. So if we are using a base class reference to point to a derived class object, then the call to a method from the base class reference should execute correctly. Okay, so what do we mean by correct execution? Let's pick an example. Okay, so suppose we created a class called student. Okay, and suppose we had public string compute grade. Okay, and we had some kind of a formula, AVG equal to 0.4 times test 1 plus 0.6 times test 2. Okay, and we said if AVG is greater than 90, okay, grade equal to 8, and so on. Okay, so in a student class, we had a compute grade method which gives 40% of the weight to the test 1 and 60% of the weight to test 2, right? Now let's go create a class called grad student, which inherits from student. Okay, and also if we wanted to override this, how should we mark this over here? Virtual, because there's a real code in it, correct? Okay, so now let's, whatever the data is, doesn't matter, let's do public override string compute grade. Okay, so now suppose our code was written as double AVG equal to 0.5 times test 1 plus 0.5 times test 2. So we are giving 50% of the weight to test 1, 50% of the weight to test 2, right? And then if AVG is greater than 90, grade equal to A, else if, let's say, AVG is greater than 85, let's say grade equal to A minus, and so on. And assume you already have declared string grade equal to blank, and over here string grade equal to blank. Okay. Okay, so now let's try to test this case. We'll use a base class reference to point to a derived class object. So obviously this is our base class, correct? In this example, and grad student is our derived class, correct? Okay. So now let's use a base class reference to create an object of the grad student. Okay, so if we did something like this, student S1, okay. So what type of reference it is? Base reference or derived reference? Base reference. So this is of type this, right? Equal to, if we allocate memory for a grad student, that means the actual object we are creating is a derived class object, correct? Okay, so now suppose we do this S1 dot test1 equal to 89, S1 dot test2 equal to 90, okay? So first let's test it this way. Suppose this is also a student. So first let me not worry about polymorphism and show you. Okay, so we are creating a student type. So the base class object is being created, base class reference is being used. If test 1 is 89, test 2 is 90. Okay. So if we did string grade equal to S1 dot compute grade, what result will it produce? If we try to display message box dot show grade, what answer will it produce? Okay, see, if you take a look over here, 89 will be given 0.4. Okay, so else, let me also put else if ABG is greater than 85. Then grade equal to A minus. Okay, so anyway, you can see this is given 0.4 weight, this is given 0.6 weight. So if we did the average, will it come out to be greater than 90?
No.
Why not? 89 times 0.4 plus 90 times 0.6. Anybody has a calculator? Sorry, that will be less than 90. Yeah, right? Will be less than 90, so let me make this way. Let me make this 91. How about making it 91? Now what will it come out to be? It should come out to be more than 90, is that right? 90.2, right? So obviously, what grade will be computed over here? A, right? Okay, so now let's go to the grad student. So let's allocate an object of the grad student. So if I change this to new grad student. Okay, so now for a grad student, okay, so now let's take a look at this statement that I made. A base class reference is used to point to a derived class object, right? Is that correct? S1 is what? Base class. And grad student is? Derived. So we are pointing, S1 is pointing to a derived class object. Then through S1, we made the call, so take a look, S1 dot compute grade. So through S1, we made the call to the compute grade, right? So which one should it call? Should it call the compute grade for the grad student or compute grade for the student?
Grad student.
It should call the compute grade for grad student because that's the memory we allocated, right? Okay, so if that was the case, then if this was the correct call, then it should be 0.5 times test 1 plus 0.5 times test 2. So now if we give equal weight over here, what will happen? The average will come out to be
90.
exactly 90,
Exactly
correct?
90.
Okay, but however the code is written, if it is greater than 90, it will be an A. So what will it compute
A
then?
minus.
A minus. So you can see if it is a grad student, the grade will come out to be A minus. If it is a student, then the grade will come out to be A. So different results are being obtained. So that's the goal of the polymorphism. So first of all, the goal is, so this is the goal. If we use a base class reference to point to a derived class object, then the correct call has to be made. Okay, meaning, in this case, it should call the compute grade for the grad student, whatever that code is. Okay, so it should call this one over here. So that's the correct call. Okay. So if we strictly go by the compiler as we discussed, okay, remember the compiler basically checks to see once we make the call s1.computeGrade, compiler will check what type is s1. What type is s1? It's a student. So the compiler's decision normally will be to call the compute grade in the student, but that will be the wrong call in this case, right? So this is where we discussed that in order to provide the correct support for polymorphism, there has to be a virtual table created in the memory of the computer, right? So how does the computer guarantees that it will not end up making the wrong call? So this is what we discussed last time. So let's go take a look. Okay, so whenever this code executes, as we discussed, if this is the CPU, and if this is the memory of the computer, okay, remember it's divided into a stack area, code area, and we take the code area, and a heap area, right? So whatever code we wrote, whatever class we created, this class we created, okay, all that code, including the UI, if we had a form, all that code will be compiled and it will go in the code area. Now, as the program is running, some variables will be created on the stack, some will be created on the heap, right? So as we have discussed before, which variables get created on the stack? Local variables in a function, the primitive data types such as int, double, those type of variables get created in the stack. So what gets created on the heap? Anytime we use the new keyword, so the new keyword means whatever memory we need over here will come in from the heap. So now let's go to this line, student S1. So remember, this is two separate statements. Student S1 means create a reference called S1 in the stack area, right? Once we go to new grad student, so suppose a grad student has a field called first name, last name, test 1, test 2, ID, thesis, right? All of these will be created in the heap area, and this S1 will be pointing to this memory over here. Okay. Last lecture we also discussed there will be one additional memory that will be created to support the polymorphism. And what's that memory called? A pointer to the virtual table, right? So that means over here there will be a V table for every class that we have created in our project. There will be a V table for student class. What else? V table for grad student class. Okay. And what is a V table? It's simply a table of function pointers. Okay, so V table is a table of function pointers. Okay, so let's pretend we also have the set and get for each one of these 6 fields over here. Okay, so how many entries will be in the V table for the grad student? So if I magnify this, what will it look like? How many entries will there be? Remember, each get and set is a tiny function. Okay, so there will be, for example, a function called get first name, set first name, correct? Get last name, set last name, correct? So each one of those properties that we write gets translated into, so there will be essentially, how many of these? If we have 6 fields over here, 12 of these. Okay, so 12 get set functions. Okay, so each one of these will further be pointing to the actual code for get first name. So whatever that code is. Okay, second one will be pointing to the code for set first name, and so on. So this table simply points to the actual code for the function, and all of this is in this code area. Okay. What additional method do we have inside the grad student? Compute grade. So there will be one entry over here, code for compute grade. And where will this be pointing to? See, all this code will get compiled compiled into the machine language. Wherever it's stored in the code area, this pointer over here will be pointing to that code. So that's the one which will be pointing to 0.5 times test 1 and so on. Okay. What about in the last lecture, we said there's one additional pointer over here inside the V table. And what will that be? Okay, last lecture we said there will be a pointer to type info. So every class maintains a complete detail about itself in the code area, which is called the type info. So if I further now okay, so what will the type info? So again, there will be in the code area, there will be type info for student with a lot of information. There will be type info for grad student. And again, with a lot of information. So this one over here will be pointing to over here. One of the pieces of information in the type info part, so this is type info part, will be the name of the class. Name of class equal to grad student. For example, over here we'll say name of class equal to student. Then further, as I mentioned briefly in the last lecture, there's a lot of additional information that's put over here. For example, how many fields it has, okay? How many methods it has. What is the name of each method? What is the name of each property? If there's a method, for example, compute grade, what data type does it return? For example, it returns a string. So there's a lot of detail over here, which is maintained one time. So it doesn't matter how many objects of the student or grad student you create. There will be a single copy of type info for each and every class in the code area, okay, with a lot of detail, or each and every detail that we may want about that class is put in the type info, right? Okay, so if we wanted to know, for example, suppose somebody wrote a function, and the function was called void print object pointed to. Okay, and suppose it takes an object over here, obj. Okay, so our goal was, and suppose this is in a class called XYZ, and suppose this is public static, so that we can call it without having to create an object of this. Okay, so now our goal was, if anybody calls this method, remember last time we discussed the base class of all classes is object, right? So what is the base class of grad student in our case? Student. What's the base class of student? Object. So, if we wanted to write a general function which can operate on any class, okay, then easy way is to make the parameter of the base type, because remember, base class reference can point to any other class. Okay, so if our goal was somebody calls like this, so pretend we have this code was written in a button handler. So you created a form, in one of the buttons you were writing this code. Okay, now you also wanted to write over here XYZ dot print object pointed to, and you wanted to pass S1 over here. So take a look over here, what will happen? S1 will go and be passed as the object, right? Okay, so in this method, if we can have the capability to start from S1, okay, so see S1 is same as object, right? So if we can have start from here, come over here, then if we can go from the vtable pointer, so this vtable pointer, what type of object is this now? Student or grad student? Grad student. So from here, if we can go from here to here, correct? And then from here, if we can go to the type info, we will be able to find out the grad student, right? Okay, so now let me introduce another concept, okay, called reflection. So reflection is basically a capability to be able to find information about an object at runtime. So while the code is running, if you wanted to know, for example, in this method, which object is S1 pointing to? Is S1 pointing to a student, or is S1 pointing to a grad student in this method over here, right? So first, before I write the code, I'll show you in plain English for reflection to work. So reflection internally uses type info. If this type info was not maintained in the code area, reflection will never work. Okay? So once again, even though the name may seem confusing, what's the purpose of reflection? Purpose is to be able to know where one object is pointing to at the very basic level. Further, as we go keep going in this class, towards the end of the class I will show you using reflection, we can create very powerful code implementations. For example, let's say we have a lot of computers available over here. So this is computer 1, computer N, right? Computer 2 or computer N over here, right? Okay, so we receive a request to execute a code, some useful function which will take many hours to execute, right? Okay, so rather than executing on this computer, then 1 hour later returning the reply, what if we can do this? We can go to another computer, meaning forward the request to another computer which is sitting idle and have it execute dynamically whatever the request is. If another request comes in from another client, then it can send it, if this computer is busy, it can send it to another computer, right? So, but each code may be different. So if we wanted to, at runtime, make a decision, what should we do, what parameters should we pass to that particular function, then reflection makes it easy. So anyway, towards the end, I'll show you how we can create mechanisms like this. But for right now, suppose our goal was simple, and our goal was find out which class this object is pointing to, okay? So again, in plain English, what we'll do is we'll start from here, go to the actual object, then locate the vtable pointer, go to the vtable, then locate the type info pointer, go to the type info, then read the name of the class, and we'll be able to find out whether it's pointing to a grad student or a student, right? Okay, so because reflection is a fundamental capability for advanced programming, both Java as well as C# provide very good support for reflection, okay? Because each and every object may need some information about it at runtime. So since every object, every class that we create may need this capability, so it doesn't matter we create a class called student or grad student or employee or anything, doesn't matter. Each one of these may sometimes need a capability to be identified at runtime. Okay, so what do? Suppose we call that method identify, let's pretend. And it will give us the name of the class anytime we call it. Okay, if it needs to be present in each and every class that we create. If you were developing the .NET infrastructure, and if you see a method needed in each and every class, what will you do? We take the common methods and move them where? Base class. What's the base of all classes? Object. So that means the support for reflection has to be put in the object class. Okay. So now the object class. Remember in the last lecture we said it has one method called toString, which we often override, correct? And it's declared, of course, in the object. How is it declared? It's the very top level class. Virtual. Okay, and then we can override it when we create our own class, right? Very similarly, to support reflection in the object class, the method is called GetType. So, as you can see, what's the purpose of GetType? Once again, if through anything we can call GetType, s1.getType, for example. So after we created this, we can, after s1 has been allocated some object, we can call s1.getType. So what will s1.getType do? Start from here, go over here, then what? vtable, then what? Type info, and then whatever this name is one part of the GetType. But GetType essentially will point to this part over here, the type info. Then you can further go and find any other information that you feel like it, right? As I mentioned, there's tons of information over here, not just the name of the class, how many interfaces it has, how many methods it has, name of each method, parameter of each method, return type of each method. So a lot of information over here, right? So the way reflection is implemented is once you call s1.getType, all the pieces of information over here are further put in another class called type, which is provided by the .NET library. So this TP will be now pointing to our type info. Now if you say tp.name, now it will give you the name of the class. Okay? If you say tp.interfaces, it will give you the interfaces. tp.method. So anyway, get methods will give you all the methods that belong to this class, right? Okay, so now let's come back to our polymorphism, and let me show you how reflection can also be used to support polymorphism. Okay, so anytime we write a code like this, and through S1 we are calling compute grade. Okay, so anyway. So first let me go support for polymorphism. Is provided by 3 mechanisms in C#. One is the is operator, 2 is the as operator, and 3rd is the reflection. Okay, and so to explain it further, suppose, let's go to the student class, and suppose our fields are first name, last name, ID, test1, test2. So those are the fields. No thesis over here, okay? In the grad student, suppose we have an additional field called thesis, okay? So total 6 fields over here, first name, last name, ID, test1, test2, and thesis. Over here, first name, last name, ID, test1, test2, but no thesis, okay? So now let's go over here. Suppose we created this code, S1 equal to new grad student, right? And now we wanted to, before we do anything, we wanted to set the thesis. So suppose you, after this line, so somewhere over here, you try to do this, s1.thesis equal to advanced OOP. Let's pretend this is what you wanted to set, okay? Now if you try to go to the computer, type all of this code, pretend you've created the student class, grad student class. You, in the form, you put a button. In the button handler, you are writing this line. Then you try to write this line. Okay? Immediately, you will see that this was not being recognized. Thesis is not being recognized. Okay? Why? See, compiler. Compiler does not worry about the B table or the type info. When compiler's job is to convert all of our code to machine code, right? Compiler strictly goes by what type is S1. So what type is S1? Student. Okay, it's student, right? Because this is what we declared, student. So compiler next will go to the student class and check is there thesis. There is no thesis. So we'll say I don't recognize thesis. Your code will not proceed to the next point. Okay, so But we know that we are creating memory for a grad student, and grad student does have thesis in it, right? So this is where we can use one of these techniques to make sure we are able to set the thesis through S1, okay? So if we use the is operator, our code will look something like this. If S1 is grad student, so we will do a check if S1 is grad student. Okay, now keep in mind, this is a runtime decision, okay? So when the code is running, what will the computer do? It will start from S1, then it will go to the B table, then it will go to the type info, and then it will check the name of the class if it is a grad student, okay? I erased it. Name of the class is grad student. So we'll come over here, and so if it indeed is grad student, then it will return true, right? Okay, so the problem is we still cannot say S1.thesis equal to something. Why? Once again, even though we have verified S1 is pointing to grad student, thesis is not a field of the student class, okay? So the trick in programming is like this. Create one more reference and make it point to same place S1 is pointing to. So if S1 is pointing over here, let's create one more reference. Let's call it, let's say GS. So this will be a grad student type of reference. And let's make it point to the same place S1 is pointing to. Then through GS, if we set the thesis, it will recognize it, okay? So, okay, sorry. Okay, so anyway, is the camera still on?
Yeah, it's good.
Okay, so grad student GS equal to S1, okay? So so if you just take a look at this part, grad student GS will create this reference, okay? And then equal to S1, so wherever S1 is pointing to, GS will also be pointing to. However, as I mentioned in the last lecture, C#, like Java, are strongly typed languages, meaning the type of the left side has to match the type of the right side. What's the type of the left side? Grad student. Type of the right side? Student. So again, compiler will say you cannot do that. Okay? So to satisfy the compiler, we have a concept called typecasting. Okay? So in the typecasting, what you do is you tell the compiler it's okay to convert it to a grad student. S1. So just to satisfy the compiler, this is called typecasting. It's always put in left paren, right paren. So think of it as if this is like a type conversion from one data type to another. Okay? So we are saying convert student to grad student. Okay? So now the type of the right-hand side is grad student, type of left side is grad student, so this will work. So now we can go and through GS dot thesis equal to whatever advanced OOP. Okay, so this was the technique using is operator if a base class reference is involved. Remember I said in polymorphism, it's always the base class reference pointing to a derived class object, and we wanted to be able to execute the code properly through the base class reference. So anyway, so for this capability, is operator will help us out. So
even if we don't use if statement, then it will work.
even if you don't use is statement, it will work. But the problem would be, what if, for example, somebody before calling this code, they said something like new, let's say, part-time student. Pretend part-time student is also derived from student. So this code is perfectly okay, right? So if you did not use the if statement, sorry, this should not be there. Okay, so if you did not put this, then you try to typecast it to a grad student. It will fail, so you'll get a runtime error, okay? So that's why when you are trying to convert one type to another, always make a check first. See, else you can put a message box, cannot convert, something cannot convert S1 to grad student. So this way at least the user knows they're doing something rather than it throwing a runtime error. So checking before you do a typecasting is a very good or very proper way of executing that code. Okay, so let me put this back to grad student.